I'm going to take a couple days on this section 5.8, solving equations that have radicals in them. And this section itself is going to have its own quiz. So make sure that you've got everything written down, you're paying attention. Really, I'm using this worksheet as a teaching worksheet. So we're going to go through each problem one at a time and discover some of the things that we can discover. Notice at the top of the sheet it says be sure to check for extraneous solutions. Okay, extraneous solutions are solutions that you've done all the work correctly, and then when you check it you find out that it doesn't work. So you have to throw that solution out the window and say that there are no real solutions. Or that one's out the window, but the other one I found actually works. So this is the first time in math where it's possible to do all the right work and then not have an answer that actually works. And that's called extraneous. Okay, so that's a little bit different than what you're used to, because you're used to if you did all the work correctly, you have the correct answer. So the checks are extremely important. As a matter of fact, make sure that you write that down. Checks are, yeah, 5.8. 5.8. Checks are mandatory. Okay, some solutions are what we call extraneous. Okay, in other words, meaning they are false. So it's like a false, you worked really hard and you did everything right and it's still not the right answer. Okay, and there isn't a right answer. Some of them have no solution, but it tricks you and makes you think it is, because square roots can do that to you. Yeah, I know. So we have a couple things. We have to be careful on the problem. We have to be careful on the solution. So let's take a look at number one. Number one's not really going to be too terribly bad. Okay, so we have 7x square root of 3 minus 5 equals 0. Alright, so from your best math knowledge, what would you do first to this equation, Preston?
I would add 5.
You would add 5 and you would be right. Okay, because you're trying to get x by itself, so you follow the things that you know, and we're just going to throw in a little bit with square roots. So we have left over here, we have 7x square root of 3. Now the fact that there's no symbols in here, Giovanna, what's it mean 7x square root of 3? What math operation is happening here? Times, good. Okay, so Julia, if these are all times x, how do you undo that? How do you get x alone? By 7 and the square root of 3. So we have to divide both sides by 7 square roots of 3, because they both have to cancel out. Okay? You don't like it. Alright, you're going to like the next part even less then, Preston. Because our answer is coming out ugly. These cancel out, so that's handy. But we have a problem. Good. No radicals in the denominator. Multiply it by what, Anton? What? By what? By the square root of 3. By square root of 3 over square root of 3. We don't care about the 7. 7's already rational. Square root of 3 is irrational. We have to we call it rationalizing the denominator. We're getting rid of the radicals down there. Okay, so this is actually not too bad. The numerator turns into what, Preston?
5 square roots of 3.
5 square roots of 3. And the denominator turns into what, Luke?
7 times 3.
7 times 3, which is what, Antonia?
21.
21. Okay, so that's all well and good. We have an answer, but we need to check it.
Yeah.
Okay, so what we're going to do is we're going to check this answer. I'm just going to erase the top here so that we can check it. I did keep a copy of it for the notes, but here is our check. Remember what I said, the check is important because in square root problems you sometimes have what we call an extraneous solution. It's an extra solution. It appears to be an answer, but it's a fake. So, yeah.
So is there any way to find the real one?
Well, some of them have no real solutions. You used the correct word. You used real one. There is no real one.
There's no way
So-
to know beforehand whether or not.
So you can just try forever
No.
different methods.
No, you don't try forever. If this doesn't work, then there's no
You just
solutions.
think that the rule doesn't apply to every
But there could be like
Yeah,
a solution
there's-
somewhere that we don't know.
No. If you've done all the work correctly, so this is where you got to be super careful. You've done all the work correctly, and the answer doesn't work when you check it. So this is what's dangerous because it's the first time you can check it and not know whether there was a mistake in your work or whether it's an extraneous solution. So you have to be extra careful in your work because you have to know that you're right in the work. So we're going to plug this thing in, and it looks really ugly, but it doesn't have to be that horrible. So I'm trying to see if that whole mess equals 0. Does it equal 0? Do you have a question, Preston?
What's the difference between no solution and extemporaneous?
An extraneous solution is an answer that shows up that's false, and you would then write no solution. Although some of these problems will actually give you 2 solutions. One of them will be extraneous, and the other one would be a solution.
How would you get 2 different ones if you're using the same rule?
Some of the problems will show us how to do that. So for this one, we only got 1, and we just need to check it. So here we go. The 7 and the 21 can cancel.
Oh, okay. That's better.
That's a little better. So you can if you want to. So we have 5 square root of 3 over 3 times square root of 3. So square root of 3 times square root of 3 is 3, which is 15 over 3, which is 5. So 5 minus 5 is 0. Checks out, so that means that this really is our answer. Okay, even if the check gets a little bit crazy. Okay, now quite honestly, there are some that are more likely to have extraneous solutions. This one right here really wouldn't have one. Okay, and you're going to start getting the hang of the ones that possibly might and may not as we go through. The first few really couldn't, but we want to practice doing those checks anyway because it is possible in some of them to get one of those wacky, looks like a solution, but it's really not.
Can you
Yes.
show us an example?
Not just yet because I want to build up into it. Okay, if I jump ahead too far, too fast, it's gonna. Yeah, we want to do we want to build into it. All right, let's get a new one. Let's look at number 2. Okay, right there. So we're all just copying down the same problem. This is number 2 on that green sheet. 4x minus x square root of 3 equals 6. Okay, this one has an interesting little twist to
I
it.
got it.
Okay, there are 2 x's. They're not like terms, so I can't really put them together, but I can't move the x over here either because that's going to get me nowhere closer. Does anybody have any suggestions? I think actually, okay, Luke, your hand moved first. What do you think?
You divide everything by 4.
Well, dividing by 4 isn't going to quite work. Preston, what was yours?
Alright. What I was thinking was. I got nothing.
Yeah, if we divide by 4, we're going to have a really big mess here, so that's why that doesn't work. Naomi? Dividing by the square root of 3 would still not quite get it. We'd still have leftovers. Antonia, what do you think?
Wait. Was dividing by 4 square roots of 3 work? But they're not connected by.
Dividing by 4 square roots of 3 is closer, but it's still not quite there. Our first step here is we need to factor this x out of both of these terms. Look at this. X times what gives you 4x?
4. That makes sense.
X times square root of 3 gives you
X square root of 3.
square root of 3, right? So here, okay, now you have an x almost by itself, but x is times something.
Then you divide.
So we divide by what, Antonia?
4 minus the square root of 3.
4 minus the square root of 3. This is where you have to be really, really secure in the difference between addition, subtraction, multiplication, division. Since this is all times x, you can divide by it, and it will cancel out. Okay, so this whole thing cancels, but we have a problem. No radicals in the denominator. How do you fix it, Antonia?
Multiply by the square root of 3.
No, that's not going to quite get it.
No,
The C word of the conjugate. Okay. By the conjugate, 4 plus the square root of 3. And 4 plus the square root of 3. This is what makes this section challenging, because you're taking all the things that you learned in the last 3 sections and you have to apply them to solving a problem. Okay, so the numerator is going to be 24 plus 6 square roots of 3. Okay? The denominator, now what you should have noticed when you were doing all the multiplication, what always happens to the middle terms?
They go in.
They cancel out. So let's not even write them. What's the first term's going to be? 16. And the last one's going to be 3. Minus 3. So that's a really neat shortcut. You don't have to write all that whole FOIL stuff, because it's actually a sum and a difference. So they cancel out. So the numerator is still 24 plus 6 square root of 3. And what, Preston?
The denominator is 13.
The denominator is 13. Is there anything that can be canceled?
No.
No. So we have this as an answer. We should probably check it. Yeah, probably writing it down is a good thing. Now, look, in this case, listen. In this case, the check is quite challenging. We'll do it.
Oh no.
You're going to start to recognize the ones that can have extraneous and which ones cannot. This is really a type that cannot, so, but we're going to check it anyway because I want to show you that. Okay, we want to be used to doing it, so we'll do the check for number 2.
Just leave it on the floor.
Okay, so I'm going to erase all this because I need space.
Don't do that.
I literally just got that.
The bottom right corner I'm keeping, and this is number 2. We're going to check.
Let's check this, baby.
No.
Okay, so we're trying to get a total of 6 from when we take 4 times this big mess.
Yes.
Over 13. Ooh, wow. Minus this thing times square root of 3. It's going to make me crazy, these negatives. Times the square root of 3. Okay, so,
Oh,
wait.
you got the 6.
Let's do
Or
this.
square root of 3.
Oh, we're trying to see if it equals 6. Yeah. I just figured we'd do the problem and then go back and see. So, 4 times all this stuff. So how much is 4 times 24? 98, I think, right?
It is 96.
96.
96, sorry. 96
Plus 24 square roots of 3.
plus 24 square roots of 3. You know what's convenient is everything's over 13.
Oh, that's
Okay, so that actually really is convenient because we're going to bring it over 13 in a minute, but I have minus here, square root of 3, so 24 square root of 13, square root of 3, sorry, plus, what is 6 square root of 3 times square root of 3? 6
18.
times 3, which is 18, right? Over 13. Alright, so we're subtracting all these things, right? So we have 96 plus 24 square roots of 3 minus 24 square roots of 3.
yes, please.
Yeah.
In the interest of time, we'll slow it down tomorrow. Okay.
Oh, we have 4 minutes.
Shh, shh, shh. And if you can't write that fast, then stop writing and just listen for a minute. I'm serious, because I'll give you time to go back and write it, but I want you to listen and look. So this one, and then this minus goes minus 18. Just put it right there. Over 13. Okay. What will happen with these two? They will cancel out. How much is 96 minus 18? We get 78.
78.
78 divided by 13
Wait. 6.
gives us 6. Because she was expecting it to be 6 and it actually is, it checks out. Okay, now, this, like I said, this is an oppressive check, and you're going to start to recognize the ones that are more crucial to check than others. Okay, so here is, I'll leave that up, and that's where we'll end for the day. So this is number 2's check. So that means that really, truly, the answer that we thought we got was actually correct. And I'm just going to go back and I'm going to circle it and say it's the answer, and I'll go back to that for those that still need to,
It's actually not that hard.
the answer.
You just need to follow the
Until we
rules.
get to number
Follow the rules. Slow yourself down. Some of you, your biggest problem is going too fast, but some of you, your biggest problem is going too slow. So you've got to find that happy medium. You have to practice, practice, practice so you can get fast enough with it, but then you also have to go slow enough, especially with these, because you can see it's very, very easy to have a mistake creep in. Okay, I'm going to turn this off.